I'd recommend that you watch the difference quotient video before you begin this, but here are the notes from today for the derivative and the tangent line problem. Okay, so we remember from before, the derivative is also our instantaneous rate of change. Okay. And if we are thinking about it in terms of tangent and secant lines, okay, and if I have some function, we'll just call it f of x. Okay, and let's suppose that I want to find the derivative at some spot x. Okay, so I know that the derivative is the slope of my tangent line. I'm going to draw in, here's my tangent line. Okay. What I could do is I could find the slope of a tangent line, or excuse me, a secant line, to make it as close as possible to my tangent line. So if I have x here, and then I have some change in x, okay, the two ordered pairs, the first one is going to be x comma f of x. The other one will be x plus whatever our change in x is, comma, f of x plus our change in x. Okay, and if I were to draw in a secant line for that, you can see that your secant line is not the same as your tangent line. Okay, but we would want our secant line to be approaching our tangent line by making the change in x as small as possible. So let's go back to and think about, here's kind of a picture. So let's think about the slope of my secant line. Okay, so the slope we know from Algebra 1 is y1, or y2 minus y1 over x2 minus x1. If we use the ordered pairs from our graph, it's going to be f of x plus the change in x minus f of x all over x plus the change in x minus x. Okay, now when we think about the slope of this secant line, in order to find the slope of our tangent line, we know that the change in x needs to be approaching 0. So I'm going to call my derivative, we label it as f prime of x, it's going to be equal to the limit as the change in x approaches 0 of f of x plus the change in x minus f of x all over. Now we can see from over here, it's just going to be over the change in x because the x's get crossed out. If you would prefer, you could also use h instead of the change in x. Okay, this is really key. You're going to be using this throughout your homework. Alright, so let's look at an example together. I'm going to ask you to find the slope of the tangent line to the function f of x equals x squared at the point 2, 4. Okay, so we know when it says slope of a tangent line, that's going to mean our derivative. Okay, so I'm going to use what we defined up there. It's going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. And I'm going to plug it in using function notation. So it's the limit as h approaches 0 of x plus h squared minus 8, or x squared all over h. I'm going to FOIL it out so I get x squared plus 2xh plus h squared minus x squared all over h. I'm going to keep working through this. You know how to do this. This is what we practiced in our last chapter. X squareds get canceled out, so I have 2xh plus h squared all over h. And I'm going to factor out an h. At this point I can now plug in chug, so it's just going to equal 2x. And I wanted to evaluate it at 2, 4, so I'm going to use the x value, so it looks like my slope is 4. If you want to know how to do it on your calculator, you pull up your calculator. I'm going to go back to my home screen. It will let me to do that. If not, I guess I can show you. Let's see. I guess it's not showing it to me that way. Let me see if I can do this another way. Doesn't seem to be responding to me. Alright, well, let's show it another way. You might have a little bit different of a calculator, but we can still figure it out. So I'm going to pull up this. Alright, if you have a calculator like mine, it'll be easy to follow along. If not, you might have to kind of play around with it a little bit. You're going to go to Math, go down to option number 8, which is the derivative, and enter in your function x squared. It's in terms of x, so comma x, and we want to evaluate it when x is 2. Okay, push enter, and you can see that we also get 4. Now let's say that we wanted to, I'm going to ask you to find the equation of the tangent line for example 1. Okay, so we know our slope is 4. We know you have the ordered pair 2, 4. And at this point we can just use y equals mx plus b. So plug in 4 for y, plug in 4 for your slope, 2 for x. Therefore b is going to equal -4. If you want to see those both graphed on your calculator, you can see it here that you have y equals x squared, and then you write in your tangent line for y2, and you can see that it is a tangent line at that spot. Alright, so your homework tonight is going to be homework number 1 for chapter 2.